you find any number which is both multiple of 3 and 7 from the number 1 to 20? No. That is, occurrence of one event is independent on the occurrence of other. So when you are taking two outcome, again remember the concept of combinations is used. So remember this, when you have with replacement, the total outcome changes. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So in our previous session, we have learnt in detail about the concepts of probability, that is classical approach, and also solved some simple problems on complementary events. So also we have learnt about the theorems on probability. So what are the theorems on probability we have learned? We have learned additional theorem that is based on mutually exclusive event, and multiplication theorem that is based on independent event. If not mutually exclusive and if not independent events, we have learnt about conditional probability as well as dependent event. So let us recall what we have learnt in our previous session. So if the events are mutually exclusive, then probability of A union B is given by P of A plus P of B. If they are independent, then probability of A and B is given by their product of their probability. If they are not mutually exclusive, when more than one events occur simultaneously, that is, we say the conditional probability, that is probability of A over B, or we can write B over A. So A over B means A has to be occurred when B is already occurred. So this is given by P of A intersection B divided by P of B, that is probability of B. What about when they are independent? So probability of A intersection B is given by probability of A into probability of B over A. This can also be rewritten by changing the values, that is replace A by B. In both the cases they are same. Replace A by B, one more formula you will get. So these are the formulas or properties we used based on theorems on probability. So let us learn its application on problems today. So that is, we are taking mutually exclusive events and problems on independent and compound events. That is, when we have more than two events simultaneously. So first problem, a bag contains 20 tickets numbered from 1 to 20. A ticket is drawn at random. What is the probability that the card drawn is a multiple of 3 or 7, a multiple of 2 or 5. So in our previous session, we have took the same example, but this is the extended way. We have two sub questions here. So let me take my first question, a multiple of 3 or 7. Or is nothing but union, remember. So we have 20 tickets. So my N is 20. A ticket is drawn at random. What is the probability that the drawn ticket is multiple of 3 or 7? Let me take an event A which says multiple of 3. So how many outcomes we will get from 1 to 20 where multiple of 3, which are multiple of 3. So that is, I'll say 6. You can just use the multiplication tables, 3 1s are 3 2, 3 6 are 18. So 6 outcomes you can get. I'll choose event B as multiple of 7. So you will get 2 outcomes here. So therefore here probability of A is how much? 6 by 20. And here the probability of B is, which is equal to 2 by 20. So now, do you find any number which is both multiple of 3 and 7 from the number 1 to 20? No. There are no outcomes which is a product of both 3 as well as 7. So what does it mean? That is P of A intersection B is 0. Why? Because A intersection B is an empty set here. Because you cannot find any number from 1 to 20 which are multiple of 3 and 7. So therefore, if A intersection B is disjoint, then the event are mutually exclusive. So therefore, here what happens? My probability of A or B, that is 3 or 7, can be written as the sum of their probabilities. Because A intersection B is 0. So what happens here? 6 by 20 plus 2 by 20, which is equal to 8 by 20. That is equal to 2 divided by 5. Next question, a multiple of 2 or 5. We have to select multiple of 2 and multiple of 5 as well as multiple of 2 and 5. So let me take E as an event of multiple of 5. So how many numbers I will get here from 1 to 20? So I can get only 4 numbers, that is 5, 10, 15 and 20. So which is 4 numbers. Or let me take F as multiple of 2. So M is here, you will get 10 numbers which are multiples of 2. Therefore, what happens here? My probability of E is 5 by 20 and my probability of F is 10 by 20. What about E intersection of F? That is multiple of 2 and 5. So you will get 10 and 20 as multiple of 2 as well as 5. That is E intersection F, you have 2 element. So therefore, probability of E intersection F is 2 by 20. So they are not mutually exclusive here. So clearly I can write P of E or F, that is multiple of 5 or 2. So 2 or 5 is nothing but 5 or 2. So we can clearly write P of E plus P of F minus P of E intersection F. So that is, so P of E is 5 by 20 and this is 10 by 20 and this is 2 by 20. So that is 13 by 20. So this is the answer. Moving on to the next question. What is the probability that a card drawn from a pack of playing card is diamond or a heart, king or a club, spade or jack, red color or queen? So when you come across an experiment called card, then your total probability is always 50 to remember. Here is my question. I have to write the probability value for each sub-question. Let me take my first question. You have to choose a card so that the drawn card is diamond as well as it is a heart. Either it should be a diamond or it should be a heart. So you should know that how many diamond cards you have and how many heart cards you have. So for my question A, let me take event A as selecting diamond. Let me take event B as selecting heart. So what is my probability of selecting diamond? So we know that in cards we have 13 diamonds, heart 13. Similarly, we have all of them as 13. Also, you should know that from ace to jack, all sets should contain 1 each. So therefore, you will have total 4 cards of all cards. So diamond, I have 13 cards out of 52 cards. Therefore, selecting diamond is 13 by 52. What is probability so that it is a heart? How many hearts we have? Again, it is 13 and you have 52. So now we have to find diamond or a heart. Chances of picking diamond or a heart. So do you find any heart card which is a diamond? No. So therefore the probability of A intersection B is 0. That means these events are mutually exclusive event when their probability value is 0. that is their intersection is 0. They are mutually exclusive. So what is the sum of probability? That is P of A or B. Or is nothing but union. That is equal to sum of their individual probability. So 13 by 52, 13 by 52, which is 26 by 52, which is equal to 1 by 2. Next question, king or a club. How many king cards I have? Let me take it as an event A. I have 4 king cards in each set. How many clubs I have? 13 cards out of 52 cards. So therefore, what happens here? So for question B, I am writing, if I take A as an event, so I have 4 kings out of 52 cards. If I take it as club, I have 13 cards, I have 52 cards. What about, it should be king as well as club. Club, you have 13 cards. In that 13 cards, you have 1 black king. So here you have 4 kings. So both intersection, then it is only 1 by 52. You will get only 1 card which is both king as well as it is club. So therefore, this is not mutually exclusive since the probability value is not 0. So therefore, probability of A union B is P of A, P of B minus P of A intersection B. So that is 4 by 52, 13 by 52 minus 1 by 52. So that is 16 by 52. That is equal to 4 by 13. Next question, spade or jack. The same question, you have spade 13 cards and jack 4 cards. The card which is both spade and jack, it is only 1. So therefore, it is similar to this problem. So therefore, here also, for this also, your answer will be 4 by 13. Because you have same 13 cards as, spade and 4 cards as jack. So here it is vice versa. But the value of the problem is same. Next, D. It should be red color and queen. So, how many red cards we have? We have 26 red cards out of 52 cards. How many queen cards we have? We have 4 queen cards out of 52 cards. How many reds as well as queen cards we have? That is both, it should be red and queen is 2. One in diamond and another in heart. So what is here also, this is not an example for mutually exclusive. So therefore, my probability of choosing red or queen is P of A plus P of B minus P of A intersection B. So that is 26 by 52, 4 by 52 minus 2 by 52. So which is 28 by 52. That is equal to 7 by 13. This is how we'll work the problems on mutually exclusive. If they are mutually exclusive, then the total probability is their sum of their individual probability. If not, we have to find A intersection B and we should find the value of the probability of either A or B. Next, we move on to the problems on independent events. What are independent events? That is, probability of A intersection B is P of A into P of B. So this is the probability of an event. So there comes many questions on probability that if not A, if not B, if neither A nor B. So we should adopt the concept of complementary event before solving the problems on independent event. So what are the cases they may ask? So let me read out this question and analyze the cases later. So here we have an example for a problem on independent event. The probability that Anirudh solves the given problem is 1 by 2. And probability that Akansh solve the problem is 1 by 4. If the problem is independently tried by them, what is the probability that? First one, the problem is solved. Second one, both of them solve the problem. Anirudh alone solved the problem. Akansh solved the problem. Both do not solve the problem. So these are the questions they have asked here. So I should analyze the cases. Before that, I know this. This is the existence of both A and B simultaneously. That is, occurrence of one event is independent on the occurrence of other. So here is what is given, P of A, that is half, and P of B, that is 1 by 4. So my first question is, the problem is solved. In previous session, I told you this. So problem is solved can be written as 1 minus problem not solved. So here we are going to use the concept of complementary. So here it is nothing but 1 minus P of A dash B dash. So here, before going to A dash and B dash, I know P of A. So let me calculate what is P of A dash. So P of A dash is nothing but 1 minus half, which is half. P of B dash, here it is 1 minus 1 by 4, which is 3 by 4. So these concepts I should know here. First question is, problem is solved. So as I said, problem is solved can be written as 1 minus problem not solved. So 1 minus problem. What is my A dash and B dash? So I can write it separately. Since they are independent event, I can write their product as like this. So therefore it is 1 by 2 into 3 by 4. So which is 3 by 8. So 1 minus 3 by 8 will become 5 by 8. So this is the answer for my first question. Both of them solve the problem. So here they are asked the problem is solved. The problem is solved does not imply that both should solve, either Akansh solve or Anirudh solve. The thing is here the problem should be solved. So therefore here I have to take this concept. Whereas here both of them solve the problem means what is the probability that both will solve the problem? That is nothing but P of A intersection B. So both solves the problem is P of A intersection B. Since the problem trying from Anirudh and Akansh is independent, this is equal to product of their probability. So that is 1 by 2 into 1 by 4, which is equal to 1 by 8. Next, Anirudh alone solves the problem. What does the statement means? Anirudh should solve the problem. Akansh should not solve the problem. So how I will write this probability? See here. Anirudh will solve the problem, not Akansh. I said complement can also be written as not E, not A, not B, like that. So here is my question. Anirudh only solve, not Akansh. So what happens according to the statement? Anirudh will solve, not Akansh. That can be written as B complement. So again, independent event. So therefore, this is P of A into P of B dash. So what is P of A? 1 by 2. P of B dash is 3 by 4. So therefore, 1 by 2 into 3 by 4, which is equal to 3 by 8. Next, the same thing. Akansh alone solves. Akash solves, but not Anirudh. How I will write this? D, not Anirudh, but Akansh. This is equal to P of A dash into P of B. So what is P of A dash? Again 1 by 2. What is P of B? 1 by 4. So 1 by 2 into 1 by 4, which is equal to 1 by 8. Next, both do not solve the problem. So both should not solve the problem. So what does the statement mean? Both should not, neither Akansh nor Anirudh. So both do not solve the problem means the probability will be like this. Neither Akash nor Anirudh. nor Anirudh. So what happens here? So this is equal to P of A dash into P of B dash. So here, what is P of A dash, which is equal to 1 by 2, P of B dash, which is equal to 3 by 4. So your answer will be 3 by 8. So see here, the problem is solved is different from both of them solve the problem. They have not mentioned you that who will solve the problem there. So therefore, the concept of complementary is used. That is, problem solved is nothing but 1 minus probability of problem not solved. So therefore, this is what the case here. So here only you have got already P of A dash B dash, which is nothing but both do not solve the problem. Okay, second question is both of them should solve the problem. That is, both should solve the problem. So it is nothing but A and B. That is Anirudh and Akansh. Only Anirudh solves. That means yes, Anirudh, not Akansh. Not Anirudh, Akansh. And here, neither Anirudh nor Akansh. So this is how I will write the statement so that I can clearly find the value of the probability. We'll move on to the next question. Two persons, A and B, climb a hill. The probability that A climbs the hill is 1 by 6 and that B climbs the hill is 1 by 4. What is the probability that both of them climb the hill? Only one of them climb the hill. None of them climb the hill. Only A will climb the hill. Only B will climb the hill. So I'll just write the statement for all of them. I have P of A and P of B. So the chance so that A will climb is 1 by 6 and B is 1 by 4. So therefore, probability of A dash is 5 by 6 and probability of B dash is 3 by 4. Here is my question. Both of them should climb the hill. So this is nothing but P of A intersection B. Only one of them climb the hill. So before going to this question, I'll explain this. Only A means I'll write P of A, not B. Only B means P of not A, B. You can also write like this. P of B, not A, which is one and the same. None of them means neither A nor B. So here they have said only A, only B. But here only one they have said. So not specified whether he is A or B. So in that case, what happens here? I have to choose OR condition. That is only A or only B. Both conditions I should choose. Let me solve them one by one. So here is my first question. So that is probability of A intersection B, which is nothing but P of A, P of B. So what is the product of P of A and P of B? 1 by 6 into 1 by 4. That is equal to 1 by 24. Next, I'll take this. Probability of A, B dash or A dash B. This is nothing but P of A, P of B dash plus P of A dash, P of B. Remember, the word OR represents sum. So therefore, what happens here? P of A is 1 by 6, P of B dash is 3 by 4, P of A dash is 5 by 6, P of B is 1 by 4. So which is 3 by 24 plus 5 by 24, which is equal to 8 by 24. When you cancel it, you will get 1 by 3. Next, I'll take these three. None of them will climb the hill. So none of them will climb the hill means P of A dash, B dash, which can be written as P of A dash, P of B dash. So what is P of A dash, P of B dash? 5 by 6 and 3 by 4. So which is 15 by 24. That is equal to 5 by 8. Next, only A will climb the hill can be written as P of AB dash, which is P of A into P of B dash. So P of A is 1 by 6, P of B dash is 3 by 4, which is again 3 by 24, which is 1 by 8. Next, only B, not A. So that is P of A dash P of B, that is equal to 5 by 6 into 1 by 4, which is 5 by 24. So learn how to write these statements when the events are independent. So you should be very careful while reading the statement. So note these things. So if you learn how to write the statements, then it is easy to solve the problems. Next, so we come across a type of problems called replacement problem. So here I have taken an example how to find the probability of these kinds of problem. A box contains 8 white chalks and 9 pink chalks. 2 chalks are taken at random from the box. Find the probability that both of them are pink if the 2 chalks are taken out together. So when you are taking 2 outcome, again remember the concept of combinations is used. So here I am taking 2 chalks. Here I am taking 2 chalks out of 8 white chalks and 9 pink chalks. So how many chalks we have in total? That is 9 plus 8. That is 17. So therefore my n here is 17 and I am choosing 2 chalks. And they must be pink. All of them must be pink. So therefore, how many pinks we have? I have 9 pinks. So I have to choose all of them as pink. So therefore, for pink, it is 9C2. And I have chosen the pink chalks. So here is my question. The 2 chalks are taken out together. The chalks are taken one after the other without replacement. The chalks are taken out one after the other with replacement. What does it mean? If you pick a chalk from the box, then you are supposed to choose 2 of them at a time or one after the other. But one after the other has 2 cases, that is without replacement and with replacement. So when you pick a chalk, then you can put it back and pick it again. But when you pick a chalk, you can find one more chalk from the remaining chalks. So that is what with replacement and without replacement says. So now let me find them one by one. So here out of 17 chalks, I am supposed to choose 2 pink chalks. And my first condition is the 2 chalks are taken out together. So what will be the probability? Suppose I take this as an event A, then probability of an event in the first case is if they are pink, then their probability will be equal to 9C2 by 17C2. That is equal to 9 by 34. So when you solve the combination, you will get it as 9 by 34. Next question. Next we have the chalks are taken one after the other without replacement. What happens here if you have 17 chalks? If you remove one chalk, then remaining will be 16 chalks. Again you have to take one more chalk because you are supposed to choose 2 chalks. Suppose what happens when you have taken one chalk from the 17 chalk, then remaining will be 16 chalks in the box. If you put it back, then it will become 17 only. So therefore the number of outcomes will not change in case of with replacement, whereas the number of cases will change without replacement. So therefore without replacement means when you are taken the outcome, then the remaining outcome will change. So therefore here let me write it as probability of first chalk drawn. Probability of first chalk is drawn. So when you are drawing the first chalk, so you will be having 9 pink chalks out of 17 pink chalk. But when you are removing the second one, so second chalk is drawn, so you are left with only 16 chalks and 8 pink chalks. So therefore the total probability here, so the total probability here is 9 by 17 into 8 by 16. That is equal to 9 by 34. So this is in the case of second question. So coming to the third question, the chalks are taken out one after the other with replacement. When you take one chalk, it will become -1. So remaining will be 16. When you put it back and again take, then it will be 17 only. So therefore here, probability of first chalk is drawn. First chalk is drawn will be 9 by 17 only. So you have taken one pink chalk out of 17 chalk, then you have replaced it. So again, when you replaced, so therefore probability of second chalk when it is replaced and drawn, that remains the same. So therefore here my total probability will become 9 by 17 into 9 by 17, which is equal to 81 by 289. So remember this, when you have with replacement, the total outcome changes, and when it comes back to with replacement, then the total outcomes will remain same. So therefore, the probability values change in each case. Moving on to the next question. A bag contained 10 gold and 8 silver coins. 2 successive drawing of 4 coins are made. Find the probability that the first drawing will get 4 gold and second is 4 silver coins if coins are replaced and coins are not replaced. So if coins are replaced, then L will be 18C4 only. If coins are not replaced, then L will be 14C4. Why I am writing the combination formula? Because you are choosing more than one outcomes. So therefore, what happens here for my first case? So the probability of 4 gold and 4 silver. So we have 10 gold coins. We have 10 golds and 8 silver coin. In the bag you have 18 gold. You are supposed to take 4 coins. In the first trial it should be gold. In the second trial it should be silver. So let me write the probability of 4 gold. So that is 10C4 divided by 18C4. And is there multiplication? In the second trial, since the coins are replaced, the total probability will be same, that is 18C4, but it should be silver now. So therefore, it is 8C4. So this is what the probability when the coins are replaced. What happens when the coins are not replaced? So probability of 4 gold and 4 silver. So this is what? Without replacement. So without replacement. So in the first trial, you have 18 coins. So this is your first trial. So when you remove 4 gold coins, so you are left with now 14 coins together. 14 coins. From here, you have to take 4 silver and this is your second trial. So make sure here the coins are not replaced. So therefore, probability for gold will be 10C4 by 18C4. So before the 4 gold coins is taken out, the probability will be like this. So next, and when you are taking silver coins, the total number of coins inside the bag is changed because you have already removed gold coins and you have not replaced it. So therefore, my total probability will be 14C4 and here it is 8C4. So this is about the problems on replacement and without replacement. Next, we come across problems on conditional probability, very simple problems. A card is drawn from a pack of 52 cards. What is the probability that the card is king given that card is red? So already the card is red and I have to find the probability so that the card is king. So let me write event A as card is red. And let me write event B as card is king. What I have to find? Probability so that the card must be king where it is already red. What is the probability of red cards? That is in the pack of 52. That is 52. How many red cards you have? 26 by 52. Next, what is the probability of king cards? That is 4 by 52. What is the formula for this? P of B over A is equal to probability of intersection over probability of A. So you are supposed to find A intersection B. So what is probability of A intersection B? That is, the card must be red as well as king. So how many cards you have? 2 cards out of 52 cards. So what happens here? It is 2 by 52 over 26 by 52. When you cancel all the terms, you will get it as 1 by 30. Next question. If P of A is 1 by 4, P of B is 2 by 5, P of A union B, that is probability of A or B is 1 by 2, find the probability of A over B. So probability of A over B is nothing but probability of A intersection B over probability of B. We have to find out this. But we know the formula for probability of A or B is this. Probability of A, probability of B, and probability of A intersection B. So just replace this one to here. So what happens now? Probability of A intersection B is probability of A plus probability of B minus probability of A union B. So all the values are given. 1 by 4, 2 by 5, minus 1 by 2. This is equal to 3 divided by 20. Next question. In a class, 45% students read English, 30 read French, and 20% read with English and French. One of the students selected at random. Find the probability that he reads English if it is known that he reads French. See, I have the condition he reads English when we know that he already reads the French. So therefore this will be, if I take probability of A as reading English, it is 45%, that means 45 by 100. Probability of persons reading French is, I'll take it as P of P, since it is 30%, it is 30 by 100. Both and English is given, both English and French is given. So probability of A intersection B is given 20%, which is nothing but 20 by 100. I am supposed to calculate first question, probability of reading English when we already know he reads French. Second question, probability of reading French when he already reads English. So therefore, here the formula is A intersection B by P of B. Here it is A intersection B by P of A. So therefore, 20 by 100 whole divided by P of B is 30 by 100. So when you cancel all this, you will get it as 2 by 3. And here it is 20 by 100 whole divided by 45 by 100. So when you cancel this all, so you will get it as 4 by 9. So this is about conditional probability. Next, a couple has 2 children. Find the probability both are boys if it is known that one of the children is a boy, older child is a boy. So when a couple has 2 children, I have the chances, let me write the sample space here, that both are boys, boy or girl, girl or boy, both are girls. So here I have a condition that probability that both are boys. So let me take it as A. So simple event, that is both are boys, an elementary event which contains only one outcome. So this is an example for elementary outcome. So probability of A is 1 by 4. Out of 4 outcomes, I have one outcome. According to my question A, one of them children is boy. So if one of the children is boy, I have 3 choices. Here. So therefore, let me take it as an event B. I have BB, BG and GB. So therefore, my probability of B is 3 by 4. And here, for my question B, let me take it as C. Older child is a boy. Older child is a boy. So older means only 2 cases I have. So therefore, BB, BG. So therefore, probability of C is 2 by 4. Now my question is, they are both are boys, which is already known. I have to find one of the children is a boy. I have to find the probability that both are boys. So for this question, both are boys, one of the children is a boy. So this is what I'll get, P of A over B. So that is P of A intersection B by P of B. So A intersection B is how much? So you can see A intersection B, you have only one element. So clearly I'll write it here, probability of A intersection B is 1 by 4. Because in both the cases you have B, B, B in common. So A intersection B is also 1 and probability of A intersection C is also 1 by 4. So therefore here it is 1 by 4 divided by 3 by 4, which is equal to 1 by 3. Older child is a boy. So for this question, I have my C, that is 2 by 4. So how I'll write this? Probability of A over C, which is probability of A intersection C by P of C. So intersection of C is also 1. So therefore the probability is 1 by 4. And probability of C is 2 by 4. So divided by 2 by 4. So this is equal to half. So this is how we'll calculate the conditional probability. When one event is already occur, the occurrence of another event is calculated. So this is all about the probability problems. That is, we have learned many different events from simple event to independent to compound event. So whenever the events are given, make sure that whether they are mutually exclusive or independent, so that any concept or any theorem can be used. That is additional theorem, multiplication theorem, or the formula of condition probability can be used. I hope you all understood the concepts of all mutually exclusive, independence, and whenever it comes for the problems without replacement and replacement problem. And finally, we come across the conditional probability. So make sure you learned all the formulas and all the properties of events in detail so that you can clearly, easily solve the problems on probability. So this is all about probability. We'll meet you in the next session with the new chapter, that is binomial theorem. So until then, keep watching, keep learning and keep exploring. Thank you.